In our last algebra period from chapter 2, we are learning surds. In last chapter period we have studied surds, definition of surds, order of surds, operations on surds. Now we are going to learn binomial quadratic surds. But before that we will have some revision. Now here we know that if A is greater than 0, B is greater than 0, then square root of A, B is equal to we know this rule. Also we know this formula A plus B, the second bracket A minus B. That means we know this A square plus B square. We also know this formula. And also we know that square root of A bracket square is equal to A. Also we know that under root A square is equal to A. Now we will use this concept for solving the next examples for rationalization of denominator. First we will study the binomial quadratic surd. In this chapter previously we have studied the order of the surd. Suppose now here under root A, here the order is 2, therefore this is called quadratic surd. Now here these two surds are here, root 5 plus root 3. Both the surds having order 2 and they are added here, the addition of these two surds here. So such type of surd is called binomial quadratic surd, because two quadratic surds if added or subtracted, then that term is called binomial quadratic surd. Or root 5 minus root 3. This is also called binomial quadratic surds. That means addition or subtraction of two quadratic surds for binomial quadratic surd. Now we will study these examples. In each examples here, in first bracket and second bracket, terms are same, but in first bracket there is addition and second bracket is subtraction. Here also terms are same, root 5, root 3, but in first bracket it is addition, in second bracket subtraction. So here also terms are same, root 3, root 7, but here addition, subtraction. Here also terms are same. Now here already we know this formula. That means if in first bracket A plus B, in second bracket A minus B is equal to A square minus B square. So using this formula we will find the product of these two brackets. Now see here, a plus b, a minus b. So here root a plus b root, and in another bracket root a minus root b. That means here root, according to this formula, root a square minus root b square, that is equal to square of root a is equal to a, square of root b is equal to b. That means a minus b. Now here also root 5 square minus root 3 square, that is equal to 5 minus 3 is equal to 2. So here also root 3 square minus root 7 square, that means 3 minus 7 is equal to minus 4. And here also 3 upon 2 bracket square minus root 5 square. So this is 9 upon 4 minus 5. So this will get 11 minus 11 upon 4. So here in each product, these are the product of all these is a rational number. So here root a, root b, these are the surds, and product of these two binomial surds is rational number. These are the two binomial surds and their product is 2, that means rational number. So in this case the product of two binomial surds is rational number, hence these are conjugate pair of each other. So these are the conjugate pair of each other. That means root a plus root b is conjugate pair of root a minus root b. Also root a minus root b is conjugate pair of root a plus root b. That means the product of root 5 plus root 3 and root 5 minus root 3 is rational number. Hence these are the conjugate pairs of each other. These two binomial surds are conjugate pairs of each other. That means if the product of two binomial surds is rational number, then those binomial surds are conjugate pairs of each other. Now just we have learned the product of conjugate binomial surds is always a rational number. So by using this property, the rationalization of denominator in the form of binomial surd can be done. When the denominator is in the form of binomial surd, then how to rationalize it? Now we will solve one example here. The example is rationalize the denominator here. Now here at the denominator, the binomial third is here root 5 minus root 3 minus root 3. This is the binomial third. So we have to rationalize it. For that we have to multiply numerator and denominator by its conjugate pair. So conjugate pair of is only here change is sign here, terms remain same. So here at the denominator, this is a binomial sub root 5 minus root 3 and its conjugate pair is root 5 plus root 3. To rationalize this denominator, so we will multiply numerator and denominator by the conjugate pair of root 5 minus root 3. So here is equal to 1 multiplied by root 5 plus root 3. We will multiply. Now here root 5 minus root 3 multiplied by root 5 plus root 3. Now this product is root 5 plus root 3. Now according to the formula here, 5 square minus 3 square, that is equal to root 5 plus root 3 upon, sorry, not 5 square here, only 5 minus 3. That is here 5 into 5, so root 5 into root 5 square, that is 5. That is equal to 2. Now this is, now here denominator is rationalized. 2 is rational number. In this way you can rationalize the denominator. Practice set 2.4, question number 1, multiply example number 3. So here our given example is three root 2 minus root 3. Bracket completes. Don't have the bracket 4 root 3 minus root 2. Now first we will multiply by 3 root 2 to this bracket. Three root 2 multiplied by second bracket 4 root 3 minus root 2. Now we will multiply by minus root 2 to the same bracket. 4 root 3 minus root 2. Now we will solve these brackets. So here 3 into 4, that means 12 under root 2 into 3 or under root 2 into under root 3. Now multiply 2 minus 2. So minus 3 into root 2 into root 2. Now solve this bracket. Minus 4 as it is into bracket root 3 into root 3. And here minus root 3 into minus. So this is minus becomes plus here. Now root 2. Under root 2 into root 3 it gets root 6. That means 12 root 6. Okay. Minus. Root 2 into root 2 we get here 2. And 2 into minus 3 minus 6. So here root 3 into 3. 3 into minus 4 minus 12. And root 3 into root 3 we get root 6. Now here minus 6 minus 12 we get minus 18. And 12 root 6 plus root 6 we get 13 root 6. This is our answer. This is the problem. Now question number 2, rationalize the denominator. So here given example is here root 5 minus root 3 upon root 5 plus root 3. So here at the denominator here root 5 plus root 3 is there. So we will multiply and we will multiply both numerator and denominator by the conjugate pair, which is by the conjugate pair of the denominator. So here a conjugate pair of root 5 plus root 3 is root 5 minus root 3. Okay. So now that here conjugate pair okay, then multiply numerator and denominator by this conjugate pair. Therefore, root 5 minus root 3 upon root 5 plus root 3 is equal to this as it is. Root 5 minus root 3 as it is and multiply it by this conjugate pair root 5 minus root 3. Here root 5 plus root 3 as it is and multiply it by its conjugate pair. Now product on this. Root 5 into root 5 here we get 5. Root 5 minus root 3 we get minus root 15. Now minus root 3 here and root 5 we get minus root 15. And minus root 3 into minus root 3 we get plus 3. Understood? Root 5 into root 5, 5. Root 5 into minus root 3 we get minus root 50. Minus root 3 into root 5 we get minus root 50. Minus root 3 minus 50 equal to 2. And here according to the formula 5 square minus 3 square. That means 5 minus 3. So now see here 5 plus 3 we get 8. Okay, and minus root 15 minus root 15 we get minus 2 root 50 upon 2. 5 minus 2, so 5 minus 3, 2. Now see here, both the terms are divisible by 2. If we divide both the terms by 2 we get 4 minus root 15. After dividing by 2, we get 4 minus root 15. And this is the, now here, denominator is 1. That means denominator is rationalized. Okay. In this way, you can solve the examples from practice set 2.4, remaining examples for your homework.